discussion where we talk about biodiversity in time and space.
All right, everybody, so we got problems of climate change. Overuse of resources.
Okay. Yeah.
And now we have something called biodiversity. All right, let's talk about some positives that biodiversity can give us. What are some ideas?
You have positive plant-plant interactions.
Okay, plant interactions.
With species too.
Okay, plus other species.
You could have nitrogen fixers that improve the soil conditions.
Nitrogen fixing soil health. Any other positives?
Smaller space needed
Okay.
to like grow other stuff.
Yeah, like space efficiency.
Yeah.
All right, any more positives? All right, what are some potential negatives or trade-offs?
Could a negative be the yield that you get from these systems?
Yield reduction?
Yeah. Yield and like crop growth.
Lower crop growth? Any others?
Negative plant-plant interactions.
Negative plant interactions.
More competition for resources.
Okay. Alright, any others?
But which one's right?
Well, go out and test it and see what's better. Intercropped or monocropped, and which gives you higher growth and yield.
Several days later.
I love how easily they come out.
Hey Emily, we're back from testing. So we found out some really cool stuff about really cool things.
You guys are back so soon? That was fast.
Yep, all done. Don't you remember showing us how to plant them?
So we're not digging a hole and like putting soil to the side and then dropping a plant in. Like you transplant, so everything's in 6-packs. Just give it a little squeeze. Try not to just rip it out by its head. All right, go upside down, squeeze this a little bit. Get it out, you can see it's a root ball, all right? So I'm just gonna use it at a corner. Get in there, drop that, and then you can kind of push that back in.
What is this? Beans. Squash, okay?
Corn.
Corn, all right.
So the corn's gonna be on the outside, and then the bean will be right next to it.
In the intercrop, okay? Got it, guys? Following along? Okay.
All right, so that thing is gonna get onto that, wind itself up.
You want to get them close, huh? And then do squash. Where does the squash go? So it's gonna go, you have two cold plants here. It's gonna go here, all right?
All right, so if you're using one of the long hose, just imagine you have a partner, like Amelie here. This is long, I can't reach it. She'll drop it in. All right, I hold it back, she drops it in, I let it loose.
Teamwork.
The soil kind of fills it up, all right?
Woo, that's right. Now walk me through what you did.
So after looking at these ideas, we really have to figure out, does intercropping affect yield more than monocropping? So what are the variables?
So the variables that we looked at for growth were height, biomass, and leaf count. And for evaluating fertility, we looked at pollination of the squash. And we also looked at the nutrient composition of the plants using a chlorophyll measuring device.
And then after the evaluation of our variables, we kept in mind the benefits that biodiversity brings, and we formed the hypothesis that intercropping will improve overall crop growth and yield.
And then you can look at this video to see how we did our methods.
Okay, so when we measure the height, we measure the tallest point of the plant when it's freestanding. So we don't like push it upwards to get like how tall it like is in reality. It's just like how it is freestanding, and we always measure from the base. So it would be around 29 points.
We labeled the bag with that it's the intercrop, squash, and 3.3 is the plant number. And we're cutting it off at ground level. And we'll dry it to get the dry biomass later.
We are measuring the yield of the squash, therefore we're taking all of the bags that are corn or beans and putting them on the other table, and then we will then get the squash and divide it in order to get biomass and the fruit and measure it.
What are we doing with the squash?
Prepare yield, baby.
We're sorting monocrop and intercrop, and then we're going to figure out the yield.
We're using this fruit, this squash fruit, to be our standard for successful pollination, and we have a measurement of 4 and
1.75.
4/9.
4 and some change. To determine anything larger than this will determine our fruit.
For the leaf count on the corn, this red mark is from last week, so our weekly count will start with this leaf here. It's 1, 2, 3, 4. We're not counting the innermost leaf, so this week's count for this plant is 4. And then we're going to paint the last leaf so we know where we left off for next week.
How we've been counting flowers this entire quarter is everything that has like a flower start. So this is considered 1, 2, 3, 4, 5, 6, and 7 flowers on this plant. And this we would consider 1 fruit. So this plant has 7 total flowers and 1 fruit.
So you find your flag, and it's monocrop corn 3.3, and then you grab whatever leaf you choose, stick the device like here, hear it beep, and there's your magic number, 10.4.
After taking our data, we then compiled it into graphs, and this is what we found. Our hypothesis was that the intercropping treatment would increase growth and yield compared to the monocropping treatment, and boy, were we wrong. While looking at average dry biomass values, the monocrop corn and monocrop squash varieties had larger values than their intercrop counterparts, while monocrop bean was the only one that had a smaller value than its intercrop bean counterpart. When looking at our pollination averages for squash, it also went against our hypothesis, with every single time period the monocrop squash having more flowers on average than the intercrop squash.
Only one of our intercrop squash yielded fruit.
Our chlorophyll averages also disproved our hypothesis, with every single value from the intercrop crops being lower than every single value from the monocrop crops.
So, Margot, what do you guys think? How do you feel about your experiment? What did you find out?
Well, I wrote my paper and I was kind of disappointed because my hypothesis was wrong. I don't know, it was kind of confusing. Based on my variables, I thought that intercrop was going to have a much higher yield and be much more productive. It turns out that was really wrong. Mm-hmm. The monocrop was much more productive, had a much higher yield, and I don't know.
Do you think that some of your results are off because the scope of the experiment was so limited?
I think that could be one of them. I feel like we were definitely limited for time, and also it was such a small area that we were testing, and so I don't necessarily think it's completely wrong, but also I don't know how accurate it is. I think it could definitely be done at a broader scale and be more accurate.
Do you think if you replicated this and had more time to grow different sorts of crops together, you would get different results?
I think so.
Yeah, I agree.
Alright guys, so we got our measurements, we analyzed our data, so what are some conclusions we can make?
So it seems like the intercropping system had significantly less yield and growth than the monocropping treatment.
Yeah. However, like, you know, the scope of our experiment was like so small, and within a short period of time, it's very hard to say what, like, it was very conclusive, but that's what we found.
Alright, short experiment times. So how does that help us make conclusions about what's going on with the overall problems that are linked to can potentially be solved through biodiversity, like climate change and the overuse of resources?
I think more research is needed.
Absolutely.
Definitely, probably longer experiment times.
Yeah, longer time and also a greater scale, like more than the small acreage.
Okay, so let's take a quiz on the effects of biodiversity over space and time.
Oh.
If you don't know the answer, you can Google it.
I'm so sorry.